Hello, in this video we will continue our discussion of irrational numbers by estimating their values. So let's review what irrational numbers are. Irrational numbers are any numbers that cannot be expressed as a fraction of two integers with the denominator not being 0. Irrational numbers do not terminate nor repeat when they are expressed as decimals. One example of an irrational number that we have seen is the square root of 2. The square root of 2 itself is non-integer, so it cannot be expressed as a fraction of two integers. And also, whenever we express square root of 2 as a decimal, it does not repeat nor terminate. So there is no pattern. Now let's talk about the idea of perfect squares. Every irrational number lies between two integers on a number line. The square root of a perfect square is an integer. Perfect squares are squares of integers, and a square is a number multiplied by itself. Now you'll see the first 5 perfect squares on the bottom of your screen. Noting that perfect squares are squares of integers, so 1 times itself is 1, 2 times itself is 4, and then so on and so forth. The second column has the perfect squares for 6 through 10. And this last column has the perfect squares for integers 11 through 15. These first 15 perfect squares are the ones you see most often in problems, so it's important that you get to know them and memorize them. On this slide, we will compute the square roots of the first 15 perfect squares. If you would like, now would be the time to pause your screen and solve this on your own if you would like to practice this. Alright, now I will solve this so you can check your work or see how this process works. So the square root of 1 is 1, because we've seen that 1 multiplied by itself gives us 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is not the square root, it's just 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. And the square root of 225 is 15. Notice the notation for this. Whenever you take the square root of a perfect square, the square root sign goes away, and the number has no square root around it. Our first example for estimating irrational numbers is the square root of 2. The first question it asks us is what two integers is this number between? And this is why it's important to know our perfect squares. And so it allows us to evaluate how close a square root is to a particular integer. So since it's relatively small, we will start out with 1. So 1 times 1 is 1. So the square root of 1 is 1. And then 2 times 2 is 4. And the square root of 4 is 2. So the square root of 2 is between 1 and 2 on the number line. And so now we need to plot the number on the number line as well. And so we need to figure out if the square root of 2 is closer to 1 or the square root of 2 is closer to 2. So the way we do this is count how many units a particular square root is away from a perfect square. So 2 minus 1 is 1. So for the smaller one, we put the larger number first to figure out how long it is away from the other one. So square root of 2 is 1 unit away from the square root of 1. Then for the second one, we put because we always put the larger number first. So 4 minus 2 is 2. So the square root of 2 is 2 units away from the square root of 4. So the square root of 2 will fall about right here on the number line, because whenever you evaluate it into a calculator, it's about 1.4, so it's just shy of the halfway point. Our second example is the square root of 62. So let's figure out which two integers this number is between. We know that 8 times 8 is 64. So the square root of 64 is 8. And then 7 times 7 is 49. And the square root of 49 is 7. So the square root of 62 falls between 7 and 8 on the number line. And the square root of 62 is really close to the square root of 64. So the square root of 62 falls just shy of 8 on the number line, so like about right here. Our third example is the square root of 181. First, let's figure out what two integers this number is between. We know that 12 times 12 is 144. So the square root of 144 is 12. 13 times 13 is 169. So the square root of 169 is 13. And 14 times 14 is 196. So the square root of 196 is 14. So the square root of 181 falls between 13 and 14 on the number line. Now we need to plot this number on the number line, and we know it's between 13 and 14, but we need to figure out if square root of 181 is closer to 13 or 14. And the way you do this is you count how many numbers it is away from the perfect squares. So 181 is 12 units away from 169. So we can do 181 minus 169 to give us 12. And square root of 181 is 15 units away from the square root of 196. So since 12 is a smaller number, square root of 181 is closer to 13 than it is to 14. So we'll put it just shy of the halfway point. Then our final example is negative the square root of 94. So let's figure out what two integers 94 is between. Well, we know 9 times 9 is 81. So the square root of 81 is 9. And 10 times 10 is 100. So the square root of 100 is 10. So negative the square root of 94 falls between negative 9 and negative 10 on the number line. The reason being is because there's a negative sign right in front of the square root, and we know we cannot take the square root of a negative number. So we can tell, since it's between 81 and 100, that 94 is closer to square root of 100 than it is square root of 81. So we will put this about right here on the number line, which is a little bit away from 10, but not quite.